back to First Take Math with Brian Thomas. Today we're going to work a little bit with equation thinking. Specifically, we're going to work on solving one-step equations, and the strategy we're going to use is what's called the zero pair. So an equation is very important to pick up on that when I see 7 plus 3 and I see an equal sign, a lot of people think equal sign means to just work the problem out. An equal sign also means that there's a left side and a right side, and as long as they have the same value, it's a true statement. So I don't have to say 7 plus 3 equals 10. I could say 7 plus 3 doesn't indeed equal 8 plus 2. So one of the things about equation thinking is you need to think about like try to visualize what we call a two-balanced scale. My scale looks probably more like a seesaw. So notice that if your seesaw is balanced, it has more of a straight across line. Nobody's higher than the other person. So 7 plus 3 is balanced with 8 plus 2. So this is what we call a true statement. So balance means that they are equal. Now, as far as strategy goes, with equations, what we're trying to do a lot of times is find the value of x that makes the statement true. One of the strategies is to solve for x, what we can do is use a zero pair to isolate the variable. And again, remember from a previous video, a zero pair just means you have the opposite of each number. A negative 3 plus a 3, those are what we call opposites. And if you add opposites, they will always give you 0. So look at this first equation. I have x plus 7 is equal to 10. Again, what we're trying to do is find the value of x that makes this true. Just by looking at it, I know this side is 10. I know this side has a 7. And what I'm trying to do is just figure out the value of x that makes the left side equal to 10. And we can probably see that in our head that x equals 3. And 3 would be our solution. So we really don't need this strategy to solve this problem. But as the problems get harder, we're going to need a strategy to tackle the harder problems, the ones we may not understand. Again, what we're going to do is we're going to use the zero pair to get x by itself. So what we're doing is focusing on the side with the x. And a lot of times, to solve this problem, what I will do is I will model it on top of a scale. So I'll draw my scale. I've got my x plus 7 on one side. I've got my 10 on the other side. And to get x by itself, what we're doing is we're trying to get rid of the 7 that's by the x. And what we're allowed to do is use its zero pair. So the zero pair in this case, since it's a plus 7, we can put a negative 7 over here. Let's try that again. We can put a negative 7 over here. But to keep it balanced, if I put a negative 7 on this side, I have to put a negative 7 over on this side. And what we learned is a negative 7 and a 7 are a zero pair, so they kind of divide, they kind of mark out. And we have that x is equal to then, and we know that a negative 7 and a 10, that's going to drop the 10 down by 7, and that's going to get me back down to a 3. So x equals 3 would be my solution to that problem. So notice that by getting x by itself, the right-hand side will materialize into the actual solution. So x equals 3 would work. And we know that 3 plus 7 does equal 10, and I can verify that answer by substituting 3 back in for x. Looking at this example, I have negative 10 is equal to v minus 7. So to model this, the negative 10 is on the left side of the scale, and a v minus 7, or a v and a negative 7, is on the right-hand side of the scale. And right now it's balanced. And what I'm trying to do is to keep it balanced, but I also want to get the v by itself. So to get v by itself, we have to focus on what's by the v, and that's that negative 7. And to get rid of a negative 7, we're going to need a positive 7 to make it disappear. But if I add a 7 on that side, to keep it balanced, I'm going to have to add a 7 on this side. And so what we end up seeing then is the negative 7 and the 10 is going to end up being a negative 3. And the 7 and negative 7 will isolate out, and that will give me my v by itself. So my solution then becomes v equals negative 3. And in some textbooks, they write this as a solution set. So they use these what they call braces, and they'll put a -3 inside the braces, and they'll write the answer in that notation. So that's going to conclude solving equations using the zero pair.